And here's a little diagram of what's going on. We have like, looks like a rocket, a cannon or something shooting a projectile at an angle theta, initially at an angle theta off of the horizontal. And the range is the distance between the beginning and the end of the flight of the projectile. We're trying to maximize that number. And this is a formula for that range value R. Okay, so this is a function only of theta, so we can just jump right in and find a derivative. So we're going to have b0 squared over g cosine 2 theta times a 2. That's a chain rule. And that means setting to 0, we're just going to have to solve this. That means 2 theta is n pi over 2, n odd. Theta is n pi over 4. Okay, now notice that theta, it can't be pi over 2, and it has to be bigger than 0. Otherwise, we would have other forces besides gravity acting on this object if it were shot along the ground. And if it was shot straight up in the air, it would just go straight up and straight back down. The range would be 0. So a couple of practical considerations there for the feasible domain for theta. So over here, then this is for n odd. I would start with n equal 1. They're giving me a positive pi over 4 for theta. And that would be really the only candidate that would fit this range in here. So this range for theta. So this, I got to assume this is my answer. You could test it with the first derivative test. You can also take the second derivative and test it that way if you really want. That's not too much work. Our double prime is just minus, let's see, 2 minus 4 v0 squared over g sine 2 theta. But as you can see, sine is positive in for theta between 0 and pi over 2. So certainly this whole quantity is going to be negative, which means that it's concave down, and we do have a relative maximum for any value of theta that we're using here. So that really doesn't show that we found the right theta, but we have a possible theta. If you really want to be sure, you could use the first derivative test, which would mean you'd have to set this up. So if you're willing to do this, you could. So a quick explanation: if we're at pi over 4 here, you might try pi over, I don't know, pi over 6. And over here, you might try pi over 3. And see what you get for r. Here, remember, we got a 0. Pi over 6, here's r prime right here. Okay, and at pi over 6, notice cosine of 2 pi over 6 would be cosine of pi over 3. It's a positive number. Now at pi over 3, you would end up 2 pi over 3. Of course, cosine 2 pi over 3 is negative. So you would end up with negatives in here. So we do see that we found a curve that looks like that. We do have a relative maximum there. So we're be safe with our number that we have. Pi over 4. That will give us the, this will maximize range. What is that range value? Well, we don't have the v0 or g anyway, but you can throw it in there. R would be v0 squared sine of 2 pi, so it's pi over 2 over g. So that maximum would just be v0 squared over g.